Hi, hello everyone, welcome to Jet to Mastery. In this video, we are going to discuss the solution of Leetcode 238. The question name is product of array except itself. So if you want, you can read the question. I'll go straight away, explain the question and explanation in my whiteboard. So let's take, so this is our input and output. Okay. So actually it's a very straightforward question. But there is only one trickiest part I will say at the last. So first let's explain the question. So this is our given input array. Okay, input array is 1, 2, 3, 4. What is our question name? The question name is product of the array except itself. Okay, and we need to solve with the time complexity of order of n. So that is our first scenario. Okay, first edge cases we need to solve this problem in order of n. Okay, linear time complexity. So what is the product of all the element? Okay, 1 into 2 into 3 into 4, that is 2, 3, 6, 6 4s are 24. Okay, so I'll get the total product of array. So the part is, what is our output array? So whenever you are in this element, so you need to say except this element, what is the remaining product? So 2 into 3 into 4, that is 24, right? So can I say 24 divided by this 1? Okay, so that is in the first part. Okay, what about when you are in this element, whenever you are in ith, your I is here, so your total product is 24 divided by, so except this 2. Okay, so except this element, you need to say what is that overall product. So 24 divided by 2, that is 12, is it? Okay, then next 24 divided by this element, that is 3. Okay, that will be 8. Okay, we have stored. Then 24 divided by 4. Okay, so next that will be 6, that will be stored here. That's it, right? So actually it is a very straightforward question, which means whenever you are in this index, okay, so whenever you are in this index, except this element, you need to multiply all. 1 into 2 into 4, that is 2 into 4, 8. So you will store here 8. Okay, so the approach is very simple. You can say, hey, why this is in Leetcode medium level of problem? It is a very easy kind of question, right? But now let's move to the what is the trickiest part. The trickiest part is you must write an algorithm that runs in order of n time, okay, linear time complexity, and without using the division operator. Okay, without using division operator. If you want to use division operator, the question is very simple, that is nothing. Okay, but the trickiest part is division operator is, sorry, this is the division operator is we can't use, right? So that is our trickiest part. Now let's think how to solve. So once again I'll explain the question. Whenever I am here, I need to multiply these all. Whenever I am here, I need to multiply whatever these thing except this thing. Whenever I am here, I need to multiply this thing except this one. Okay, so this one and this one. So whenever I am here, I need to multiply except this element. Okay, so that is our output. Okay, I hope you have understood the question, but without using division operator, can you think? Have you got my point? Yes, exactly. Whatever the things we have learned here, and what is our playlist called prefix array. So definitely prefix array or suffix array technique will be going to use. Okay, now how to implement those things? Okay, so my given array is 1, 2, 3, 4. Okay, fine. So whenever I am here, okay, so whenever I am here, okay, now let's consider you are in this index. Now we are explaining approach. What is our approach? Now consider whenever I am in ith index, is there any array going to give the answer from 0 to ith index of the multiple of array? Not sum of element, multiple of element, which means from this range to this range, is there any array going to give the answer of multiple of those elements? Yes, absolutely, that is my prefix array. Prefix multiplication, not sum, prefix multiplication. Okay, so whenever I am here from I plus 1th index to last element, is there any element, is there any array going to give the answer of I plus 1th index to n minus 1th index multiples of? Is there any array? Yes, that will be we will get in our suffix array. Okay, so now let's create the prefix multiplication, also suffix multiplication, prefix multiplication and suffix multiplication. Okay, what is our prefix first the given array is, suppose this is your given array nums. Okay, we can consider as a 1 2 3 and 4. Okay, fine. Okay, now let's create some very big. So this is my a, this is my a. In the a, my elements are 1 2 3 and 4. So this is my element. Now let's create the prefix multiplication, not sum, prefix multiplication. So the first element will be considered as 1. 1 into 2 2, 2 into 3 6, 6 into 4 24. Yes, I have created the prefix multiplication. Now let's create the suffix multiplication. Okay, let's start from here, the suffix multiplication, that is 4. Okay, the suffix multiplication is 4, then 4 into 3 8, that is 12. Okay, 12 into 2 24, 24 into 1 24 into 1, that is 24. Okay, this is my suffix array I have created. Now the part is very simple. Whenever you are in here, okay, now let's consider the answer of when you are in this index. Okay, how to get from till 0 to I minus 1th index of all elements should be multiplied, that we will be get from my prefix array. Okay, my left multiplication is 1. Okay, what about my right multiplication? So my right multiplication is from I plus 1th index to n minus 1th index, that I will be get it from my suffix of I plus 1th index, that is 12. Okay, so 1 into 12, my right multiplication is 12. So now let's multiply both the thing, 1 into 12 12, that is I need from this index, right? This index, that is 12. Okay, now let's consider this index. Okay, now I am in this index. What is my left multiplication? My left multiplication is nothing but prefix of I minus 1th index. From prefix of I minus 1th index, that is 2. Okay, 2. What is my right multiplication? That is my suffix of I plus 1th index. What is I plus 1th index? That is 4. Okay, so 2 into my right multiplication is 4. 2 into 4 8. That is want here. Okay, so I hope you have understood the approach. But only one edge case, what was that? So that was, so whenever you are here, so whenever you are here, okay, whenever you are here, okay, is there any element? Okay, is there any element on the left? Is there any left multiplication? No. So your left multiplication is 1 whenever your I equal to 0. Okay, I equal to 0. Else you can consider your left multiplication is prefix of I minus 1. That's it. So whenever you are here, is there any element on the right? So your right multiplication is 1. Else you can consider your right multiplication is suffix of I plus 1th index. Right. Okay, I hope you have understood the approach. Now let's try to solve. Okay, and do we need really any extra array we need to take? Already, what is our time complexity for the given approach? We are iterating from this range to till n. So my time complexity is order of n. What is my space complexity? For creating the prefix array, creating the suffix array, it will be n plus n 2n. So my space complexity is 2n. Is it? That's it. So 2 will be cancelled. So finally space complexity is also order of n only. Order of n only. Okay, now let's do the approach. Now let's code it up. Go there. Okay. So I have a given array. Let's change it as A. Okay, first let's create the prefix multiplication. Create prefix multiplication. Got it? So int prefix of equal to new int of, what is our size, that is n. Let's take an n, int n equal to a dot length. Okay, so next my prefix of 0, that will be the same, my array of 0. So now for int I equal to 1, I less than n, I plus plus. Okay, so approach is, let's create the prefix array. See, after the for loop, if you have only one statement, you don't need to put the open close curly braces. Okay, I hope you have aware of that. Okay, so my prefix of I equal to prefix of I minus 1 into array of I. Okay, so next let's create the suffix array. Suffix multiplication, create suffix multiplication. Got it? So int suffix equal to new int of size n. Okay, so suffix of n minus 1th index should be stored by array of n minus 1th index. So let's start for int I equal to n minus 2. Okay, so I greater than or equal to 0, I minus minus. Here also I have only one condition, so I'll write it as here suffix of I equal to suffix of I plus 1th index into array of I. Okay, array of I. Now I have created. Now let's create the answer array for storing purpose, or else you can store for the given array itself. It's your wish. I'll just rewrite from the given array. I'll just store this index, this index. I'm not going to create the new extra array. Okay, so I'll just rewrite in from given array itself. So for next fill answers. Okay, for int I equal to 0 to I less than n, I plus plus. Okay, now the trickiest part is we have edge case. If your I equal to 0, before that we need a two variable, that is your left multiplication, also your right multiplication. If your I equal to 0, your left multiplication is 1, is it? Okay, so else you can say your left multiplication is equal to prefix of I minus 1th index. Okay, if your I equal to last element n minus 1th index, you don't have any right element, so your right multiplication is 1, else you can say your suffix of your right multiplication equal to suffix of I plus 1th index. Got it? Okay, now your a of I, your a of 0 should be filled by left multiplication into right multiplication, left multiplication into right multiplication. That's it. Our part is, that's it. So finally return your answer array. So they are given the array name as A, and finally I have written into A. See, okay, let's run. What happened? Okay, accepted. Then let's submit. Yes, submission also working fine. I hope you have understood this problem. If you have any doubt or if you want me to explain further, just put it and comment. I will catch up you in the next interesting video, guys. Until then, bye bye, take care.